and I'll use this one for questions. So, hopefully, there is at least one burning question within yours. This one doesn't work unless people ask questions, panel sessions. Chris, always reliable, thank you very much.
So this is Chris Brown. Can you hear me?
Is it on? Yeah, try again.
This is Chris Brown from in Cambridge. So if I talk to our unit verification guys, simulation guys, they'll tell me, if you run more of my stuff, I'll find more bugs. And if I talk to our formal guys, they say, if you run more of my stuff, I'll find more bugs. And if I talk to our system level guys, they say, if you run more of my stuff, I'll find more bugs. And I only have a finite amount of resource, be it people or computers or whatever. Have you got any advice for me to figure out who I should believe and how I should compare all these competing technologies?
So, Brian, I'll jump in. You should obviously believe the formal guys. No, I think that it's a case of not who needs to do more, but actually targeting the right solutions at the right problems. So your formal is going to be much better targeted at these control path level, block level. You're going to find a lot of bugs easily using formal at that level. Then save your simulations for a bit more higher level verification. Save your simulations for actually checking this at the higher SOC level and making sure that your integration's been done correctly and doing these bigger things. So I think that there's obviously all these technologies are going to find different bugs. So we've all got advantages and disadvantages in each space. And I think it's less about which one do we do more of, but more about where do we apply them and when we apply them.
Right. That matches, I mean, that's pretty much matches my experience. And I know Arm's very good about measuring, you know, so I mean, I think the best thing to do for your project, right, is to actually look at where you're finding the bugs the most, right? But I generally agree with Ian that's consistent with what we see, you know, and obviously, you know, finding much more of the bugs at the lower level, I even like your idea of unit testing, you know, finding the bugs in the test bench before you get into the design, I think is the way to go. It's all about who can find the bugs the earliest. It's not who, you know, because I don't want the system guys finding all the bugs, you know, even if they could, that's not effective.
Did you want to say?
I guess my observation would be one of your principal problems has nothing to do with those bugs, but actually persuading your licensees to use your stuff correctly. And that I guess is the other aspect that comes in with these things. That is you know, it's not just those aspects. It's to do with how these things get used in bigger systems. And I know that you've been wrestling with, you know, you give really good advice which doesn't necessarily get listened to, or actually does get listened to but doesn't necessarily get understood.
Well, you could stop asking them. That's always the other solution. I've got a question, maybe initially at Peter, but maybe Ian and Mike as well. You talked about sort of systems, and with AI, there's emergent properties, or we don't always know what that system is supposed to do, which gives us a big challenge in verification, especially the way we do hardware verification, where we've got a model comparing to the system, for example. Well, do you see any solutions to overcome the fact that we may not always know what that system is supposed to do when we verify?
So I think part of what I was looking for there is firstly the recognition that is actually how most systems arise nowadays. They don't necessarily get used anywhere near the way that you expected them in the first place. That's an important thing to recognise. But then the second sorts of things, they're looking far more at how these sorts of things will fail and how they will continue to provide residual capabilities. Seemed to me to be something that was important in going forward, and an ability to reverse in some of the testing on things. You know, it seems to me that, you know, all the studies we've done over the last 50 years indicate that things come out of things we don't expect. So, you know, we've been fortunate I guess in this area that we've been able to test things and do things in the way we have, and I guess that's just one of the things we're having to learn to embrace at the moment of this emergence. I would say, generally speaking, I can use things to do totally inappropriate things so long as it's not at any scale. Yeah, so I can bang in nails with forks in the garden if I need to, but it's not the best thing to be doing it with. And yeah, and those things of actually recognising changes of what you're trying to do may allow you to get things into place soon enough to do something.
Actually, I think doing gardening is the thing you're doing wrong. Anyone add anything, Mike? Ian?
I suppose one thing to add on this, without wanting to appear like I have a completely blinkered view of the world, is that actually not understanding what the design is supposed to do is another great application for formal, because it forces you to think. The tool is going to generate counterexamples for you if you don't put constraints to block out certain stimulus. So then you present a designer with a thing and says, well, what about this? And what about this? And what about this? And it actually enforces designers to then actually go back and say, I haven't thought about that, or yes, I know exactly what's supposed to happen here. So it makes people think more rather than kind of just throwing some stuff at the wall and hoping it's correct.
Right. Yeah, Yoav, if you remember, a guy started Vericity, he's starting a company called Fortelix, and they're working on verification of autonomous vehicles. So I've been talking with him some, and I think it's sort of the back to the future, the infinity minus the concepts from Speckman, where, you know, the amount of crosses, in a similar way you're talking about with formal, the amount of crosses of the space that you need to look at with the environment, people, cars, et cetera, is so massive. So it's going to have to be something where you won't be able to define all of the checking up front, right? It's about, but just being able to actually stimulate the environment and exercise it will bring about, you know, the ability to observe, you know, the types of issues that you could encounter. But by itself is a big problem. So I don't know how we're going to do exhaustive level, you know, checking. So.
Watch this space, eh?
Yeah.
There's a question over here. Yeah. Just introduce yourself first.
Yeah, hi. Probably I will stand there. Yeah, hi. This is Devjit from Cirrus. I was just wondering if formal analysis data can influence the constraints used in the UVM-based test benches. For example, as I understand, formal tool already have analyzed the design a lot. So it can, because it already has broken the design into multiple cones and all. So it probably can understand that this cone, can be exercised using this bit fields. So I can put probably better constraints on that. So is there any way to put the data from the formal analysis to the?
So, you can use the data if you want to. If you verified something already using formal, that piece of logic's already been verified, then I would argue that at least for sort of unit level simulations, you don't need to be worrying in the same way about that same thing. So you don't necessarily want to take that there. You can generate information, and some of the things we've been talking about relating to coverage and completeness information, you can take that and you can compare it to your simulations and see what's being covered in different technologies. You can also, using formal technology, identify unreachables in your test bench, which can really help with kind of coverage closure. So rather than wasting time actually trying to see which things are hard to hit with my stimulus and which things are impossible, formal tools can generate you that as well. So yes, in a sense, you could generate that information from your formal environment, but I wouldn't necessarily recommend that it's the best use case for it.
Mike?
I agree completely. That's
You've got a good agreement between Cadence and Synopsys. You heard it here.
Anas Srinath from University of Bristol. So my question is, if we have an AI-based verification system that we have tested for fault injection, and it turned out that it's working probably for, I don't know, many of these fault injection things, and it's failed to falsify a given requirement after so many runs, when can we decide to stop and claim that this requirement can be held by our system? So
the easy questions.
Is it? So yeah, this is the question: is after how many runs can we be satisfied that this requirement is true?
Right.
Thank you.
It's a good question. I don't have a good answer, actually, for an autonomous system, right? I mean, that's changing. You're talking about for a learned training set, or it's actually changing over time? I mean, because
yeah. What I'm referring to, like, to verify an like neural network or machine learning system, if we are verifying anything, but we are using the AI to generate the test cases.
Yeah.
And then we tested it using the fault injection. We tested our verification method by the fault injection, and it's turned out, okay, it's doing well for, I don't know, 50, let's say, the fault injection things. And then we run our verification method, that's AI-based verification method, against given requirement, and this our verification things failed to produce counterexample, let's say, after 100 runs. Can we say, okay, that's look like, sounds good, there's nothing wrong with our system with respect to the given requirement?
I mean, yeah, I would start with capturing some formalism of the requirements, if when you say AI-based test environment, I'm not exactly sure what that is, but independently, I would start with some formalization of how are you defining the requirements, right? What are the features that you're actually trying to test? And then having some measure that you can formally measure that you've actually achieved that. And, we talked about different things in formal that you can use to track that. There's different types of coverage you can use in simulation. I would use some metric like that to give me some measure of, okay, did do enough testing? I think it's the same. I don't know that it would be any different than from what I'm doing with human engineering.
Yeah, I would agree. I think if you break it down into the stimulus, the coverage, and the checkers, you're automating stimulus on the AI. I think Mike just said you keep your checkers and your coverage in place, and that's still you've got your same sign-off criteria effectively.
But there's an aspect there that's an important thing on AI, isn't it? It's an important thing on AI that one of the things it's not good on is being able to say that there are definitely no counterexamples it's going to find. One of the things it's really good on is finding creative examples. So you may be better at actually finding something, that was wrong, but the question you asked is exactly the one you can't get an answer to.
Ian?
I agree with Mike and Peter.
Okay, so I think we'll go to the final question. It's one online, and it follows on from that question: is how do we think AI will impact the way we do our verification?
So, as I mentioned, we've been doing a lot of research. So, I mean, the main thing with AI is you need data sets and training, right? And so we've been looking at it more from a regression perspective, right? Naturally fits. There's a ton of data there. Both there's coverage data, there's data in terms of runs data, failure data, we see at least the low-hanging fruit, the biggest opportunities are in being able to look at trying to optimize various cost functions for your regression, right? Is it that, hey, I just made a bunch of changes in the design and I would like to somehow intelligently find a set of tests that will quickly give me some higher confidence that I've, soaked that area, is there some kind of correlation that can be determined by looking at some input constraints, if you're looking at, say, a constrained random environment, to areas where you're trying to really go focus to go for more bug finding? Or are you trying to achieve some coverage goals? And again, there's learning can be made between the inputs in terms of constraints and tests that you're injecting and the actual coverage goals you're achieving. So so that whole space, and depending on which knobs you want to turn, I think that's a big opportunity that we're exploring.
I agree. I think regression testing is a great place to start because it's where you have the most data, and there's lots and lots of things going on and lots of time that you can try and improve performance on. So we're looking at it in terms of how you can take your regression runs and how you can learn something about those in order to improve things going forward. Again, for things like, I'm going on about again, but the formal technology is a good way to actually kind of develop better learning and better understanding of which engines are better suited to which types of problems. So this is kind of a human learning activity at the moment where we have to spend lots of time learning which kinds of problems and what kind of data sets you can break those problems into. So which kind of things are going to work better with a PDR engine or a BDD engine or SAP-based problems. So we can learn more and more through lots of data going forward, and then actually apply that to future revisions of things, such that you can get much faster results. So I think that performance is going to be a big thing which is affected by AI and machine learning.
I guess I need to give a different answer then, don't I? So I think it will start to bring in some really interesting areas to do with adversarial attacks, and I think that will transform some of the things that we actually need to do under V&V, and particularly that'll start to mean that we start to recognise different things that are inside there that we've not been looking for, that we've not been exhibiting. Yeah, particularly in terms of some, some of the lower level primitives that we're actually looking at that people are trying to attack our chips on, or they're attacking our systems on. I think those seem to be areas that are particularly promising for machine learning things, and certainly that's the things that I'm seeing people starting to bring, and seeing those sorts of things come together is what I will expect to be seeing, I think, over the next couple of years.
Right. Okay. Well, I think we'll wrap up the panel there. So thank you to Ian, Mike, and Peter.